Hi there, thanks for watching. My name is R.Whitehead. I'm an Associate Professor of Architecture and a Faculty Fellow for High Impact Practices at the Center for Excellence in Learning and Teaching, or CELT, at Iowa State University. This is one of a continuing series of lectures in which we talk about inquiry-based or even project-based learning education. The first of the 5 basic steps is to understand the potential learning impacts of inquiry. Focus on the why. In order to do this, I would like you to think about an educational experience that you've had that was impactful. What was the context of this learning? What was the activity that you remember doing? And who was involved? My guess is that whatever you thought of would be part of what's known as a high impact practice, a learning that's somehow situated within research or mentored learning, learning through travel, learning with community, learning in context with a project. If you look at the educational objectives here, it's about a broader way of being involved in your learning, being able to understand and navigate information that's been presented. This is a constructivist view in which learners are expected to take an active role in their learning by making sense with what they encounter. In both the Kolb model and Bloom's taxonomy of higher order thinking, there's a value to experiential learning, to being involved and active in the learning experience. There's various ways, of course, to do this, but having the right learning model or an inquiry model to have these experiences happen is key. Research has shown the effectiveness of this inquiry-based approach on student engagement, skill development, communication, and content retention. A few of the philosophical roots in learning sciences behind what one can get in an inquiry-based or project-based approach. Active learning is a deep understanding that occurs when a learner actively constructs meaning based on experiences and interaction in the world, versus perhaps a superficial learning if it's passively transmitted. Active construction is oftentimes linked to what do professionals or experts do? How do they do it? What do they produce? Etc. Situated learning is the most effective learning occurs when learning is situated in an authentic and real-world context. Students see the value and meaning of the tasks and activities they perform to themselves and the value to their communities. The knowledge and skills matter. Social interaction, a collaborative group such as teachers, students, and community members all join together within a situated activity and help construct a shared understanding. In this case, learners develop understandings of principles and ideas. They do so through sharing, debating ideas, basic collaborating with a back and forth. Cognitive tools and metacognition. There are particular tools and practices that encourage students to learn how to learn. These tools might amplify how students learn by enhancing their visualization of either data or physical properties, etc. This may involve haptic engagement or even computer simulations. Incorporating a range of tools into the learning process expands opportunities for students to learn in different ways, or I should say, learn how to learn in different ways. Which gets us to a very common arrangement of what's called the gold standard of project-based learning developed by the Buck Institute. In that, they have 7 essential project design elements, starting with a challenging problem or question, a sustained inquiry, authenticity, student voice and choice, reflection, critique revision, and a public product. It's worth pointing out that all of these have a gravitational center of the overall learning goals. What's the key knowledge, understanding, and success skills necessary for the project? You can see how the Kolb model, Bloom's taxonomy, and active, situated, social interaction, and even metacognition all work incredibly well in concert with these overall essential project elements. Step 2, define the nature of the inquiry, finding an engaging topic and a driving question. Not all inquiries are the same. An inquiry-based approach essentially takes a problem and a solution, and it nurtures the curiosity of learners of how they get from one to the other. So what skills would be involved in this? And that's the issue that we're really trying to figure out and trying to determine the format of an inquiry-based approach. Because we live in a world of interconnected problems, and making sense of them and acting upon them usually happens within the context of a particular project. We have to put together or assemble research, design ideas, and an evaluation in order to get from a problem to a solution. This comes in various forms. One might be a direct task approach, in which a particular problem that has, say, a right and wrong answer, like sizing a beam for a building. Now, that's a useful information. It focuses on comprehension and direct application, and this information is essential. Designing a building without the ability to size a beam wouldn't be sufficient. But when a curriculum is filled with direct tasks without inquiry and without a framework for exploration, then the learning process has a limited range of higher order thinking. The next step forward might be a problem-based solution. In a problem-based solution, a real-life problem that needs exploration to develop and test with various solutions. The problem given by the instructor is, how can we introduce this particular genetic strain of crops to a new region? So it's a teacher-defined problem, and it focuses on the application of that specific knowledge. Now, there's still many possible solutions, and learners would, of course, still have to do research. They'd have to generate different ideas, and they'd have to evaluate those ideas, but they may come up with various answers to that. It's not just something that could be Googled to understand what the right or wrong answer is. Expanding this a little bit further to a project-based approach, you can see the guiding question of this one would be, what effects will introducing GMO crops have on the region? Shifting to a project-based approach is no longer just about moving from a problem to a solution. Instead, learning happens through this process. The students, in fact, help define the problems to solve through their engagement across this whole process of learning. The distinction here is the inquiry is situated within a particular project. How it's situated relates to the nature of the prompt, or, in this case, the guiding question. The question invites exploration into what will be explored and how it will be explored, and even what will be produced. The sort of broadest realm of inquiry-based education is the design thinking approach. Design thinking approach embraces the idea that we live in a complicated world in which our problems aren't easily defined, and the solutions are less evident, or perhaps vexingly out of reach for a traditional academic inquiry. For example, why isn't food safe, or what makes food secure, or who's hungry and why? It's hard to imagine the traditional academic setting would be able to make sense of these type of inquiries. Design thinking is another option that's used when this broader range of inquiry is desired. Implementing a process or structure is important to include. It may seem as though it's open-ended, but it's really not. In design thinking, learners help define a particular trajectory of where they're going to be going here, and they oftentimes include projects and problems and even direct tasks in that inquiry. All of these inquiry-based approaches deal with the nature of the guiding question that prompts the inquiry. There's some hints about what to do and what not to do to make a good guiding question for an inquiry-based approach. Notice all the questions on the left are things that are facts that could be found through basic research. We realize they could be rewritten. Trying to answer the questions that we see on the right elicits a desire to learn and provides a foundation to scaffold concepts and class activities and basic principles. All of the questions on the right are more meaningfully anchored in real-world situations, and it illuminates an important problem or learning objective for the course. The distinction between the bad guiding question and the good guiding question is evident. In step 3, where we learn to envision the final objectives and artifacts, the suggestion here is to think about backwards design. And backwards course design is a planning framework that'll help you to teach in a more goal-focused or effective way. It allows you to align short-term plans and actions with the long-term goals. By envisioning where you want to end, it allows you to work back to the beginning. 2 quick examples of projects that I've worked on. Both of these have quite different final outcomes related to both the learning objective and the amount of time on the schedule. This is a 1-week project. The guiding question for this 1-week project is, what are the spatial and material qualities for a space that promotes mindful living? Working backwards from there, you have to figure out what type of learning is evident and then what process could lead them to this particular artifact. In this second example, the guiding question was, how can designers meaningfully engage with disaster relief and resiliency efforts? This was a 10-week process for an interdisciplinary class, and this is a team of 4 students. This design proposal shows a synthesis of empathetic research, discovery, design, and evaluation through prototyping. All of this would have been absolutely impossible in a shorter class with fewer people. In both of these things, I was able to consider what the outcome could be, what the learning objective could be, how much time I had, how large the teams were, and from there I was able to work backwards and still construct guiding questions that are still rooted in authentic and real-world explorations. But by working backwards, I was able to limit the amount of exploration as needed in order to meet the objective. Step 4, who's involved and how? The idea here is to nurture collaborative learning. Because the problems are generally multifaceted and interdisciplinary, particularly when they're situated in authentic scenarios, it's best to address different perspectives in a collaborative and ideally integrated manner. We want students to have a voice and choice. We want to include reflection and critique. And in doing so, then, they have to learn from each other. And importantly, this means that one's role as an instructor is a facilitator and a collaborator as well, not the keeper of knowledge. So ask yourself, who are the people involved? There's a traditional way of an inquiry-based approach in which there's an instructor and an expert and a student, and they're around a disciplinary specific topic and skill. Of course, even in this traditional approach, this can be problem-based, project-based, or design thinking. It's just simply who's involved and what's the nature of the topic. Another approach, if you really wanted to try to get at a more integrated or transdisciplinary topic, you might consider having multiple instructors or a co-instructor. You might, in fact, want to have students from various majors that participate in that class. In doing so, then the nature of the collaboration and the expertise, of course, expands. Further, you might consider involving a community entity, either a community service or a sponsored studio project. In that, again, you might have co-teachers, you might have students from different majors, but now the community is both an entity that helps shape the project and give feedback to everyone else that's involved. And feedback is incredibly important. Formative and productive feedback is key to a successful inquiry-based project. Finding the right tools for the various phases is something that is essential to nurture. There's quite a few tactics that are involved in inquiry-based learning that involves ways of making sure that there's creative activities and research activities and evaluative activities, and all these demand certain prompts. And these prompts then are part of a larger framework that you want to nurture with an inquiry-based approach. Which brings us to step 5. Link the learning across the activities, but try to be flexible in how you do it. This learning doesn't occur all at once, and it doesn't occur easily. If you use a guiding question for the project, and you use backwards design for the solution, we then want to be able to fill in with research of knowledge and skills, and creative problem-solving knowledge and skills, and evaluation knowledge and skills. And then the inquiry process is where this targeted learning occurs in each and every one of those phases. It's a way of scaffolding the project. So what actually happens in each phase? Generally, there is a discovery and ideation, an experimentation and evolution process. And within each one of the processes of this overall activity of inquiry are different activities or tactics that are related to each. In discovery, you might find empathetic activities or immersion or observations. There's tools that are associated with each as well. So for example, in ideation, we might use visual or tactile, experimental role-playing, storytelling. In the experimental phase, these are more about applying the efforts and using and nurturing different knowledge and skills. And eventually the evolution is about rethinking or redesigning or repeating. And so with that is where we'd focus on targeted improvements and assessment. One way of envisioning the overall scaffolding of the course, starting with a guiding question or working backwards from the backwards design process. And we find that again, it goes through several phases, and these phases then can be aligned with different modules. You see that in discovery processes, we're learning more, so it expands. After we interpret it, we're narrowing our options. We then go to ideate, so we expand our options, test it, narrow, and eventually evaluate and implement until we get to the final presentation. So we narrow our options but expand our opportunities. But this diagram is a bit more reflective of the idea that the work is produced and built, and builds and builds and builds upon itself as the semester continues. You start again with the guiding question, and through the discovery, interpretation, etc., you're having more and more evidence. And this is the linking of the different processes together throughout that makes it so that when you get to a final presentation, it isn't about 2 weeks worth of work. It's about an entire semester's worth of work in and around a larger process of inquiry. Of course, this can change depending on the type of inquiry process. Let's say, for example, in this one that a person wanted to focus more on ideation and prototyping. In this one, let's just say it has to do with a skill building and specific production objective. So then you could change the modules and change the amount of time spent with each phase in order to tailor it specifically to what you were looking for in the class. Here's an objective in which, let's say this had to do with community service learning, some sort of engagement. And so the amount of time spent is more with expressions of engagement, and that's the objective. So you lengthen the discovery and empathize phase. You increase the amount of community consultation. But all those have sort of shown a single trajectory. What we know as an inquiry-based course is students can embrace the multiplicity of considerations found in these questions and find their own trajectory from the project guiding question to the final public presentation. As students discover, develop, test, and present their work through these various stages of activity, they learn by doing. So managing, of course, the trajectories and making sure that trajectories are all still pointed at the various project proposals and final goal, and then layering different modules and module activities that are oriented towards either helping with the understanding, applying, analyzing, evaluate, and create. There in the very middle axis, you see those are the sort of Bloom taxonomy, higher order thinking skills. They can all be coordinated. So those module times and those specific lessons are then taken and embraced by each team along their path. If you use the particular qualities, the essential project elements for project-based learning, the authenticity and the student voice and choice and the sustained inquiry and things like that, and if you really want to cultivate the active construction and situated learning and social interaction and cognitive tools and metacognition, there's a whole lot of different project-based learning or inquiry-based teaching tactics that apply here. So remember, understand the potential learning impacts. Focus on why. Define the nature of the inquiry. Pick an engaging topic and really cultivate the driving question. Envision your final objectives and artifacts and work backwards. Determine who's involved, how they're involved. In doing so, you can nurture collaborative learning. And finally, nurture this inquiry process as well. Link the learning across different activities. Be flexible in how you do it. So there's a few essential elements to this. What I've found in my years of practicing in this way is trusting the creative process is key and essentially doing your best and understanding that the work itself needs to be nurtured. It's not easy, it's not direct. It may not even be how you've been taught or how you've learned to learn, but it's worth it.